So in this video I wanted to showcase the Rockstar G7400 Pentium CPU, which I was able to obtain from the depths of Asia like 2 months ago or so. So back in May, I think. That very same CPU is on the right hand side of the screen right now. So this CPU over here. This CPU pretty much holds nearly all of the important overclocking record scores on hardwarepod.org at the moment, or at the time of making this video, like Geekbench 3 multi-core, Citybench R15 11.5, Y-Cruncher 1 billion, GPU Pi for CPU 1 billion, etc. What makes the CPU very interesting is, well, first of all, that this CPU has the halo marking on top of the word Intel, which indicates that this CPU does have AVX-512 support. I already covered that topic back in early June, which was actually posted on many tech media news websites around the world, like Video Cards, Tom's Hardware, Geek Guru, etc. So AVX-512 is pretty much like a premium feature from Intel, which is mainly meant for the very expensive CPUs, like the Cascade Lake X CPU, the 28-core Xeon from Intel, and pretty much all of the very expensive Xeon CPUs. So it's pretty awesome to actually find that feature enabled on a retail CPU that costs only 70 or 80 euros on the retail market. So pretty interesting. And the AVX-512 is extremely important on any software that can utilize those instruction sets. That was the only reason why I was actually so interested in this CPU back during that time, because I wanted to get G7400 CPU that has AVX-512 support to be able to try the top score in Y-Cruncher 1 billion, for example. That test can utilize AVX-512 instruction sets, so it's impossible to do or to beat the top score in that specific test if you don't have AVX-512 support on your Alder Lake CPU. And it seems that same thing applies to Geekbench 5, for example. And that was kind of sad, as in the Intel Masters of 12th Gen competition, Geekbench 5 was the first stage of the whole competition. So if you didn't have AVX-512 supported CPU, you were pretty much in very big trouble if you wanted to do a very competitive score in that whole stage of the competition. Yes, it has the halo marking, but the batch number over here doesn't make any sense. The batch number is very new if you look at it. The batch number is V, which should mean China, 2, which means this year, so 2022, 11, which means for week 11, and F, 0 and A and 9. So the batch number or the date of this CPU is week 11 of 2022, which doesn't make any sense at all if we look at the CPU that's on the center of the image at the moment. So this CPU I actually purchased myself from the retail market here in Europe. This is a Vietnam batch CPU, so X202, which means January of 2022 and N326. I actually already covered this CPU very briefly on my channel, but this is very early 2022 batch CPU, and it already has the rectangle marking over here, which does indicate that the AVX-512 has been disabled at the hardware level already at the factory by Intel. So the batch number over here doesn't make any sense. This CPU that's on the left hand side of the screen is my most recent G7400. It is also purchased from China. It has the halo marking on top of the word Intel. The batch is X1, so it means Vietnam 2021, week 46, M820. So all of the like retail G7400 CPUs that do have AVX-512 support are dated at the very end part of 2021. So you cannot, it should be completely impossible to find AVX-512 supported CPU that has a date mark at early March of 2022. So after I discussed about this whole thing with other guys from the community, for example Obscure Paradox from the United Kingdom, who works at scan.co.uk if I'm correct, he has access to tons of different CPUs, but according to him, this is an engineering sample CPU with some completely random batch marking on top of the IHS, and that seems to be the case. When I install the CPU on any Z690 motherboard and open CPU-Z, for example, CPU-Z and other software read this CPU as engineering sample, like Benchmade does as well. So that should be the case. This is pretty much an engineering sample G7400, but with very random batch or retail marking. I have never seen this kind of engineering sample CPU in my life before. Usually engineering sample CPUs are marked in a completely different way compared to retail CPUs. They have like Intel Confidential marking and then some 4-digit marking to indicate what engineering sample or qualification sample of that SKU the CPU actually is. So I thought about testing the CPU for the first time on water cooling with you guys. I haven't tried the CPU on water at all. The same thing goes for this CPU over here as well. I only tested these on LN2. The one on the center I did test on water. It did 5.4 GHz in Cinebench R20 on water. It was the second best CPU based on water tests, but it was much better on LN2 than my very best water CPU. The very best CPU did 5.5 GHz in Cinebench R20 with like 1.4 volt or 1.45 or something like this, and it had very hard time to run very high speeds on LN2, or at least it was very hard to control. This CPU did 5.4 and it was able to do Cinebench R20 etc. at like 6.25 to 6.3 GHz, so pretty good result if you ask me. This CPU holds all of the top scores like I already said, so it does 6.45 to 6.5 GHz on LN2, highest Baseclock was 176 to 178 MHz. This CPU I only tried briefly. It can post and boot even 6.5 GHz, but the effective clock doesn't go high enough. I think the CPU could still be very strong after like fine-tuning on the voltages etc, but it's definitely harder to run than this CPU over here. So it seems, so if you want to find a CPU for like extreme overclocking, you cannot trust the air and water cooling results too much. Even if you find a CPU that's very good on water, there's absolutely no guarantee that it will be very strong on LN2, and you will be surprised, trust me. So far this CPU doesn't seem to be the strongest at all on water, but it's a complete rockstar on LN2. So the only thing that seems to matter with the G7400, and I think that applies to other non-K CPUs as well, is the base clock scaling. But anyways, so let's install this CPU on the EVGA Z690 Dark Kingpin. Let's take a look at the CPU inside the BIOS and inside the operating system and how well can it actually overclock. And let's just see how the CPU actually looks like. So without further ado, let's get the whole rig set up and let's see how it performs. Okay, so if we take a look at this interesting G7400 inside the BIOS, we can quickly note that the stock VCore, or the so-called VID, is around 1 volt for this CPU. Sometimes it will read at just below 1 volt, like 0.998, or a tiny bit over 1 volt, like right now 1.004 or 1.007. This is the very same thing as the SP rating on the Asus motherboards. So the SP rating is pretty much like a quality rating that's based on the stock VCore or the VID. The lower the VID is, the higher the SP rating will be. So it's pretty much the same thing, but you can't really compare VID values or the SP rating between two different vendor motherboards. So it's a bit difficult to compare, as many people ask about the SP rating of some of my CPUs, as I don't have any Asus Z690 based motherboard at the moment. But anyways, so let's take a look at the settings to overclock this CPU now on water cooling. Usually if you are just starting, I would just go to the extras and load some of the profiles. The 6800 Class 30 Kingpin Geekbench 3 Hynix profile is very good if you are looking to like just overclock and test Hynix based memories. But if you just want like a very suitable daily oriented profile, there are those available as well, both with Samsung and Hynix based memories. But now, so for the G7400, the maximum multiplier for the core is 37. The multiplier is pretty much the same for cache as well, but you can't run cache and core like successfully with 1:1 ratio. The cache needs to be set lower than the actual core. Good multiplier is usually like between 31 to 33 in my own testing, so I will start with a value of 32 over here. The AVX negative offset is a little bit tricky one on the non-K CPUs. They don't always work the very same way as on the unlocked CPUs, but with the G7400 the negative offset does work, so I will just put negative offset of 1 for AVX1 and AVX2, and that will also cover AVX-512 at the same time. So I don't need to set lower multiplier for AVX-512, and bear in mind most of these CPUs don't have the AVX-512, but this particular CPU does have it, as we already checked. So just a ratio of 1 over here. The heat loads on these dual-core CPUs are relatively low, and I have pretty overkill cooling solution for this kind of CPU at the moment, so I don't really even need any like higher negative offset than 1. Baseclock set as high as you want to get the desired end frequency. So now I'm setting 5.3 GHz on the CPU with 143.3 Baseclock. Then you don't need to enable extreme voltage mode. You only need it if you want to set higher memory voltage than 1.6. VCore at override mode, 1.38 volts should be pretty good, as this is a dual core CPU. Voltage range can be between 1.35 to 1.4 if you have at least somewhat decent cooling. Low line calibration at -75% minimum droop. VCore PWM switching frequency, best value is between 600 kHz and 800 kHz. Sometimes you might find that, for example, 650 might be a tiny bit more stable than 800, but usually that's the best range, and more than 800 usually just hurts. VDDQ at 1.26, and input can be from auto to 1.9 volts, so between 1.8 and 1.9 volts. The rest can be auto. Memory, you need to set the multiplier according to the base clock, so as we have so elevated base clock, we need to set the multiplier lower, so I will use 4400 to get 6.3 on the memory. And I forgot to mention FLL override. The BIOS suggests you should use mode 3, but the FLL override is actually bugged on the G7400, and that's why the clock speed is bugged when you run the CPU on LN2. You might see 6.5 GHz on CPU Z, but the real frequency under actual load, like Citybench, can be just at 5.8. So you can actually just leave it at auto for the most part. You can test it. You can test this out yourself if you don't believe, but it's actually bugged on the G7400. On the 12300 it still works for the most part. Memory, as I said already, like on one of my earlier videos, the IMC is not very good on these locked CPUs like G7400, 12300. The maximum memory frequencies I've been able to run have been between 6800 to 7000 with command rate 1, and even with command rate 2 the memory frequency doesn't always go much higher than 7000. Like compared to 1200K and KS, etc., I have been able to run the memory at well above 8000. So I would aim for at something like 6.3, so 6300 mega transfers per second with command rate 1. Try to get pretty decent subtimings, etc., and you can then try to push the frequency higher if you can, but don't expect too much. Generally, with these CPUs on air and water cooling, if I try to go for very high, like a multiplier, I usually get very weird debug codes and it doesn't want to post successfully. So I'll just use 6.3, 1.435 volts, which is the maximum value without extreme voltage mode, or it does go to the red area. So I was actually incorrect, so the value is actually lower this time, after which you need the extreme voltage mode. So it wasn't 1.6, it was DDR4 CAS31. It does work on this motherboard model, also on the Z690 Dark Kingpin. Odd CAS latency values will work just fine. So 31, 39, 39, 28. These can actually go even lower, like 38, 38, I think. 28, 46, 14, 23, command rate 1. You might need PMIC turbo mode at mode 4 to get command rate 1 to work. Command rate 2, you don't always need to even touch the PMIC turbo mode, but you need to use it for command rate 1. write recovery time of 12, 360 on TRFC. This one, the best value would be at the maximum value. We can actually try to set it straight away. And I will just leave the sub third timings at auto. I might actually set 4 and 4 on the last of the third timings, which are quite important. But the memory frequency from the IMC side is not very good. IMC will always scale quite a lot when you run the CPU on cold, so that's why it's very sensible. If we are limited to like 6.3 to 6.4 on water, we can push the memory up to 7000 when the CPU is at very cold temperatures. But yeah, that's pretty much it. And if you use PS2 keyboard, make sure you enable the PS2 device's support for a fast boot, so that you can re-enter the BIOS if needed be. But yeah, so I'll just do F10, 7 exit, and let's see if we can run these settings inside the BIOS. I mean inside the operating system. Okay, so I managed to boot in the operating system, but it's pretty flaky, I can already say it from the get-go. So 5.3 on both of the cores, 143.3 times 37. Mainboard, better BIOS from last March, but the latest ones are pretty good as well, or pretty much the same. Memory at 6300, 31, 38, 38, 28, 66 command rate 1, and cache at close to 4.6. We can try, but I think, and it actually hang already. So I might need to try lower frequency, like 5.2 or 5.25 with 1.4 volts and see, but we can already say from the get-go that this CPU from the G7400s I've tested this far is by far not the best on air or water cooling. But yeah, very interesting. So this doesn't really seem that good. So now 5.2, 1.4 volts. So this might be the edge really. So 5.25 failed at 1.38, and now 5.2 might be solid at 1.4 volts. Might still fail in Y-Cruncher, but that will have the negative offset, of course. So if this is like this, it's pretty funny because this is my very best CPU on LN2. This is the one I used for all of the top scores. My best water CPU was 5.5 at this voltage, 300 megahertz lower, I mean higher, but it was much worse on LN2. So it seems you can't really indicate LN2 capability based on air and water results. Seems G7400 is pretty random for that purpose, because it's mostly about the BCLK or Baseclock stability. So 760 points did pass just fine. Now R20, but I will of course do most of it off camera to cut the video to a shorter length. So let's just fire this up so that we can at least see it will not fail during the first few seconds. So temperature is somewhere around 60 degrees Celsius. Still pretty warm for dual core CPU, and this was 1.4 volts. And now we could pass just fine. So 5.2, that will be pretty much it, I think. Now, as the highlight of this video was AVX-512, as you can see in the instruction sets list in CPU-Z, we have AVX, AVX2 and AVX-512. So the halo marking on top of the word Intel. The only test from the completed tests on hardwarebot.org which can utilize AVX-512 fully is Y-Cruncher. Geekbench 5 can utilize that instruction set by a tiny bit, but not in like same measure as Y-Cruncher, for example. So we can try to run Y-Cruncher 1 billion to demonstrate AVX-512 and AVX overall, and we can also see the negative offset, the impact of negative offset when we run this. So we only set negative offset of 1 for AVX2, which also covers AVX, and nothing on AVX-512. But we do have negative offset of 1 at the moment on both of the cores, even when we are utilizing AVX-512. So we don't need any lower multiplier for this kind of workload. The temperatures are in the same range as in Cinebench, or can actually be even tiny bit cooler. Buildzoid already covered that AVX-512 is actually easier on the Alder Lake compared to AVX2. So you should be more worried about AVX2 than AVX-512 this time around. But let's look at the result itself and just see what kind of numbers we get when it finishes the cache is still at the same level, so it doesn't actually impact cache when we set the negative offset, I mean. So 4358 on the cache and 5.2 to 5060 on the core. So we should be getting a score right now. 72.210, same speed on the cache and 5.2 on the core. And if I think we could still check, so we could see it through the whole run. So we had 5060 effective clock during the actual run and 5.2 CPU Z. Now if we check the actual performance, how it compares to other guys in the community. So over here is Y-Quantum 1 billion list with G7400, and if we select H2O, so water. Okay, actually now, so water, we have multiple different results with much higher frequency, and they are still significantly slower than what I got over here. The first one over here is at 5.4 effective clock, under load was 5255 and 5.4 CPU Z, and this CPU did support AVX-512, as we can see in the CPU Z instruction sets. The result was roughly the same what I got, like 1 second difference. Very small difference overall, if you ask me. And here is another run, also on water cooling at 5.6. It's a bit hard to see, but actually if we look over here, so I'll close that one so you can see, the effective clock on this one had been at 5.6, 5625 CPU Z, and also effective clock. And look at the performance, 86.273 with our AVX-512. So you can see, if you calculate the percentual performance difference between these two CPUs, it's absolutely massive. It's huge, if you ask me. So you definitely want to find AVX-512 supported CPU among any of these Alder Lake CPUs, if you ask me. Especially if you do any kind of workstation use that can utilize those AVX-512 instruction sets. The performance difference is massive, and remember, you pay nothing for it as long as the CPU actually supports it. So huge, so good job Intel for making this mess for us, the consumers. But yeah, if you look at the difference, so 86.273 at 5.6 compared to my run at 72.210 at 5060 megahertz, so 5.06 gigahertz, so almost 600 megahertz lower frequency, like 550 to 600. The memory was even better on this run, so it was at almost 6700 with 30, 38, 38, but command rate 2 and better cache and everything, and we just absolutely dominated this run. Of course, you can impact the overall performance by messing around with these settings, but as we look at the other runs over here as well, they are pretty much the same. These are absolute trash compared to our run. So I think that kind of proves it, if you ask me. I might quickly save this one and then just wrap this whole thing up. The hardest part about the G7400 is the memory, as I already said. So if I try to run any higher memory multiplier, it would often give very weird debug codes overall. So it's very hard to get very high memory on these locked Alder Lake CPUs. But even, I think, if you ask me personally, the 6300 or even under is still pretty good overall. So let's just save this one like this. And that's pretty much it. So for the memory, as I already said, the IMC is very limited on these locked CPUs. So I tried to boot 6748 with command rate 2 and it would just hang at debug code of 7F. So I would just stay somewhere around this mark, like 6186 to like 6373. I think this could be the maximum for me, so I could try to run this with command rate 1. I would like to stay at this voltage range for daily use on the memory, and these sticks have been tested for 6933 to 7000 daily on a 1200K. So it's not the kit, itself, it's the actual IMC. And I don't want to push the VDDQ like extremely high on air and water cooling. So I would just push the sub timings to decent values at this kind of frequency and just let it be. Double check the stability with HEIMM test at full capacity, and if it's stable, you should be good to go, pretty much. So I'll just try this. So one multiplier higher than what we just ran. And okay, that's pretty much it, I guess. So the next multiplier, so close to 6400 on the memory, it hang pretty quickly during this test. But now I managed to cover the entire capacity with 100% plus coverage on the same multiplier I used at the very start, so between 6100 and 6200. And remember, these sticks are again tested for like close to 7000, so it's pretty much the IMC. So I would, in this case, I would just aim for the best possible timing configuration at this frequency. So we have the highest refresh interval and everything right now when we ran this whole thing, so close to 6200. I think the cache latency could come down a little bit to like 29, maybe even 27. So just wanted to point that out. So that's pretty much it, I guess. But the biggest like surprise of this whole video was how bad the CPU actually is on like air and water cooling. So for those guys who want to try the G7400 and pretty much all of the non-K CPUs on cold, you cannot trust the air and water overclocking results too much. 5.2 at 1.4 volts, yet being the very best G7400 in the world. And there are 5.5 to 5.6 GHz, even over 5.6 GHz capable CPUs in the world. So pretty amazing if you ask me. But again, the biggest thing, I think, like what should be like the main guide for the Void audience was the AVX-512. How massive the performance difference is with, I mean, when you compare a CPU that doesn't have AVX-512 to a CPU that actually has it in a workload that can utilize AVX-512 fully. So the performance difference was absolutely massive. But yeah, so that's the end of the Rockstar G7400 engineering sample, or weird retail. I don't know how to call it. It is an engineering sample CPU with retail marking on the IHS, whatever. This is how it performs on air and water cooling. Give me a thumbs up if you like to see these results and this testing. Subscribe to my channel. Maybe check out my Patreon page as well if you want to support my work. And thanks for watching one of my videos once again. And I will see you on the next one.